Hey guys, today we are continuing our investigation of rational functions. Now, we graphed rational functions previously by using vertex form, which gave us a, h, and k, but a lot of our rational functions that we see do not have those. A lot of our rational functions look like this, like y equals x plus 3 over x squared minus 3x minus 10. It's not as pretty. It doesn't tell us what a, h, and k is, and so we need to know how to investigate stuff like this problem. That way, we can find what we need, our domain, our range, our asymptotes, stuff like that out of it. So the way we do this is there's some rules. We look for the horizontal asymptotes first, and then we look for our vertical asymptotes, okay? And there's 3 rules to find your horizontal asymptotes. And those rules all apply to which one is bigger, the numerator or the denominator. If the numerator is bigger, it affects in a certain way. If the denominator is bigger, it affects a certain way. And if they're the same, it affects a certain way as well. So we have a specific set of rules to help us remember that. But before we investigate, we need to talk about what our degree is for the top and the bottom. So the way we find our degree is we look and find what our highest exponent is. So for instance, for this polynomial, my highest degree is 3, so that gives my polynomial a degree of 3. For this one, we have a degree of 1 because my highest exponent is 1. Remember, if you don't actually have an exponent showing, but you have a variable, it's an exponent of 1. But if you do not have a variable, it's an exponent of 0. All right, so there's the 3 rules. First off, if my degree is bigger on bottom, we use a phrase called Bobo. This little dog's name is Bobo. And he tells us that if our thing is bigger on bottom, y equals 0. So if my degree is bigger on bottom, we are going to have a horizontal asymptote of y equals 0. So just like that, we're able to find the horizontal asymptote for our graph. And that gives us a lot of information about our graph. So as we look down here, take a look at this one right here for me. This one, sorry about that. This one down here on the bottom. This one is a Bobo graph because my degree on top is just 0 and my degree on bottom is 1. So my bottom is bigger. So bigger on bottom, my horizontal asymptote is going to be y equals 0. So that's our first rule. Our second rule is bottom. Bigger on top, no horizontal asymptote. So if it's bigger on top, no horizontal asymptote. Okay? So bigger on top, no horizontal asymptote. Let me give you an example of that. This one down here. Our third one here. This one has a degree of 2 on top and a degree of 1 on bottom. So that shows me bigger on top, no horizontal asymptote. Okay? No horizontal asymptote. And our last thing, so that's bigger on bottom, y equals 0. Bigger on top, no horizontal asymptote. But what if they're the same? Well, if they are the same, it's called eats DC. If these two are the same, if exponents are the same, we're going to divide our coefficients. So to find our horizontal asymptote, if they are the same, all you have to do is divide the numbers that are in front of my equation. Okay? So take a look here. We have on this one, my degree on top. My degree on top is 2. So degree on top, 2. Degree on bottom, 2. So we take a look at my coefficients. My coefficients are my numbers in front of my polynomials. So my number in front here is 1. My number in front here is 5. We're just going to divide those two to find my horizontal asymptote. Okay? So that's really all there is to it. To be able to find our horizontal asymptote, we either do Bobo, bottom, or eats DC. Now, how do we remember those 3? That's where that dog comes in. Now, that dog, silly name, but it helps us remember. That dog's name is Bobo Button. All right? That dog's name is Bobo Button, and that dog likes, as all dogs like, to eat dog chow. And so that's where eats DC, eats dog chow, comes in. All right? It's silly, but it helps us remember it. Okay, now that's how we find horizontal asymptotes. How do we find vertical asymptotes? Well, vertical asymptotes, all you do is you find the undefined values in our graph. Do y'all remember when we would factor the denominators and we would set those parentheses equal to 0, and that would be our undefined values? Yeah, that's exactly how we find the vertical asymptotes as well. So we use these three rules to find the horizontal asymptotes, and we find the undefined values to find the vertical asymptotes. And that's really all there is to it. Okay, so with that in mind, let's turn the page and let's talk about what happens if there is no horizontal asymptote. Now, if there is no horizontal asymptote, sometimes it creates what's called a slant asymptote. So a slant asymptote occurs when the degree of the polynomial in the numerator is exactly 1 more than the degree of the polynomial in the denominator. To find the slant asymptote, you must divide the numerator by the denominator using either long division or synthetic division. Now, we're just going to focus on long division. And I know it's been a while since we've seen this, but I promise it's not nearly as hard as it seems. So all you do is if there's no horizontal asymptote, we are going to divide the top by the bottom. And whatever our answer is, that's going to tell us what our asymptote is going to be, what our slant asymptote is going to be. And we ignore our remainder. It'll make more sense after we try it. But what it happens to do is it creates graphs that look like this, that have this like slant to it, okay? And that's because what we're really doing is my asymptote is a real line that doesn't just go up and down or left and right. It actually goes at an angle, okay? So let's take a look at number 1. And this one is going to have a slant asymptote. So first off, we're going to investigate. And when I investigate this, we're going to take a look and we're going to see, okay, my degree on top, the degree of my numerator is 3. The degree of my denominator is going to be 2. So that means, you guessed it, bigger on top, no horizontal asymptote. So I am not going to have any horizontal asymptote. However, we can have a slant asymptote since I'm missing the horizontal asymptote. And to find my slant asymptote, we'd have to divide the top by the bottom. So what we're going to do is we're going to take our top here, which is going to be x cubed minus 9, and I'm going to have to put in some placeholder zeros so I can divide. So I'm going to go x cubed plus 0x squared plus 0x minus 9, and we're going to divide that by x squared. Now, I know it's been a long time since we've done long division, but we're going to do it a couple times here, and hopefully you'll catch back on. So, x squared. To get from x squared to x cubed, we have to think, what do I need to multiply by? And to get from x squared to x cubed, I need to multiply by x. So I'm going to multiply by x here, and x squared times x is x cubed. Okay, so then we'll subtract x cubed minus x cubed. It cancels, that's 0. So we're going to bring down my next number, which is 0x squared. Oh, hold on. X squared can't go into 0x squared. We would just be multiplying by 0. Okay, what about the next one? No, x squared can't go into 0x either. Oh, and x squared can't go into negative 9. So that's it. My answer is just going to be x. And listen to me. Negative 9 would be my remainder. I would have a remainder of negative 9, but we don't care about the remainder for this problem. Okay? We only care about the number that turns up here. So we're going to have a slant asymptote of y equals x. Okay? So we're going to have a slant asymptote of y equals x. All right. Now that we've talked about horizontal asymptotes, slant asymptotes, let's refresh ourselves on the vertical asymptotes. Now, your vertical asymptotes are just going to be whatever our undefined values are. And remember, to find what we do to find our undefined values is we set our denominator equal to 0. Okay? So what I'm going to do here is I'm going to take that x squared, set it equal to 0, and that's how we find our undefined values. Remember, we take our denominator, we factor it if we have to, set it equal to 0. Well, to be able to find 0 here, to find what x is here, we would, we would square root both sides to get rid of that squared, and I would get x equals 0. The square root of 0 is 0. So I have an undefined value of x can't equal 0. And so if I have an undefined value of x can't equal 0, that's going to be my vertical asymptote. So we're going to have a vertical asymptote at x equals 0. Now, if my vertical asymptote is at x equals 0, that's going to help me write out my domain. That means that my domain is really just going to be whatever my vertical asymptote is as well. So my domain is going to be all real numbers except x can't equal 0. And we can also write that like this. We can go negative infinity to 0, union 0 to positive infinity. All right? Okay, so that's really all there is to it. We just think, is it Bobo, Botten, or eats DC? We use that to find my horizontal asymptote, or if it's Botten, my slant asymptote, and then we find my vertical asymptote by finding my undefined values, just like we used to do whenever we would factor and set those equal to 0. So let's turn the page and let's work through a few together. So take a look at number 2 here. So number 2, we have on top 5x squared plus 1, 2x squared minus 8. So my degree of the numerator is 2. My degree of the denominator is 2. Okay, if those two are the same, then that means that that is an eats DC problem. Eats dog chow problem. It's going to be exponents are the same, divide coefficient. So we look at my two coefficients. I have a coefficient of 5 and a coefficient of 2. So that means I'm going to have a horizontal asymptote of those two divided by each other. We're going to have y equals 5 over 2. And that's going to be my horizontal asymptote. Okay, now, I do not have a slant asymptote. Okay, so then what we can do is we can take my denominator off to the side and we can set it equal to 0 to find my undefined values, to find my vertical asymptotes. So I'm going to take this 2x squared minus 8, we're going to set it equal to 0, and we're going to factor it and solve my factors. So I'm going to first pull out a GCF. And my GCF for this is 2, so we're going to have 2 times x squared minus 4. Hopefully you remember how to factor difference of squares. X squared minus 4, perfect difference of squares. So we are going to change that to be 2 times x plus 2 times x minus 2. Okay, so remember, your undefined values are going to be the opposites of your factors. So my undefined value for this one, we're going to have x equals negative 2, x equals positive 2. So my vertical asymptotes are going to be x equals negative 2 and x equals positive 2. That helps me write my domain. My domain is going to be all real numbers except x can't equal 2 or negative 2. And we can write it out. So think about it. My graph's going to go from negative infinity to negative 2, from negative 2 to 2, and then from 2 to positive infinity. So let's write that out. Write kind of small on this one. Negative infinity to negative 2, union, negative 2 to 2, union, 2 to positive infinity. Just like that. All right, take a look at number 3 now. So number 3, we find our degree of the top is 1, right there. My degree of the denominator is 2. So this one's going to be Bobo, bigger on bottom, y equals 0. So we'll have a horizontal asymptote of y equals 0, and we'll have no slant asymptote. My vertical asymptote will take my denominator here off to the side, and I'll factor it. We'll have x squared minus 4x minus 5. That can factor to be x minus 5 times x plus 1. Remember, we can use x and plus to factor that. I just did it in my head. Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. All right, so that's going to give me my two undefined. We're going to have one of x equals 5 and x equals -1. So there are my vertical asymptotes, x equals 5 and x equals -1. So my domain is going to be all real numbers except x can't equal -1 or 5. So it's going to be -infinity to -1, union -1 to 5, union 5 to positive infinity. Okay, number 4. Number 4, my degree of the numerator is 1. My degree of the denominator is also 1. So this one's going to be eats dc. Exponents are the same, divide coefficients. So what are our coefficients? Well, I have a coefficient of 2 here and a coefficient of 1 here. 2 divided by 1 is 2. So we're going to have a horizontal asymptote of y equals 2. Then we're going to take my denominator off to the side, set it equal to 0. We'll have x plus 1 equals 0. So we have a vertical asymptote of the opposite, x equals -1. So we're going to have a vertical asymptote of x equals -1. So that's going to tell me what my domain is. So I have all real numbers except x can't equal -1. It's going to be -1 to -infinity to -1, union -1 to positive infinity. And I forgot to write that I do not have a slant asymptote. All right, here is our last one, number 5. Number 5, my degree of my numerator is 2, degree of my denominator is 1. So this one is bigger on top. My degree on top is bigger than my degree on bottom. So this one is going to be bottom. So that means I am not going to have a horizontal asymptote, and we are probably going to have a slant asymptote. So remember to find your slant asymptote. We need to take the top and divide it by the bottom. So I'm going to go x squared plus 0x minus 9 and divide that by x plus 2. And we're going to go, we're going to have to multiply out. Notice how I switched these? I just wanted to write my x in front. Makes it easier. Okay, to get from x to x squared, I need to multiply by x. X times x is x squared. X times 2 is 2x. And then do you remember me saying draw the line, change the sign a long time ago? So we're going to draw the line. We're going to minus this one, x squared minus x squared cancels. 0x minus 2x is -2x. Bring down my -9. Now we're just thinking, okay, what do I need to multiply x by to get to -2x? Well, I'm just going to multiply by -2. So -2 times x is -2x. -2 times 2 is -4. We're going to draw the line, change the sign. It's going to become a plus. It's going to become a plus. These two cancel. -9 plus 4 is going to be -5. Okay? So, my your remainder doesn't matter. Remainder doesn't matter. What matters is our answer. My answer is going to be x minus 2. So we're just going to have a slant asymptote at y equals x minus 2. For our vertical asymptote, take our original over here. I'm going to rewrite it as x plus 2. And then we're going to solve, and we're going to get x equals -2. So my vertical asymptote is going to be at x equals -2. So we're going to have a domain of all real numbers except x can't equal -2. It's going to be -infinity to -2, union -2 to positive infinity. Okay? All right. So that kind of gives you a breakdown. What I'm going to do is I'm going to show you a little bit of the homework, some answers to the homework. That way that can help you. So let me pull that up. So here is our homework page. And as you can see, you can pause as we go. Here's the answers for number 1. So that's a Bobo. Here's the answers for number 5. That's a Botan. And here's the answers for number 6. That's an Eats DC. That way, you're able to get started on those. Remember, you can check your answers on GoFormative, and you can always let me know if you have questions. All right, guys. Thank you so much. Hope you have a great rest of your day.